Good evening. I'm afraid I must begin with some sad news. We've lost two of our greatest men, the great radio astronomer Sir Bernard Lovell, and also we've lost Neil Armstrong, the first man to set foot on the surface of the moon. And of course we were talking about those, but on the good side, the Curiosity probe has landed safely upon Mars and is working well and sending back a mass of information. With me is Chris Glentott.
Evening, Patrick. I can't wait to talk about Curiosity, but we should start by talking about both Neil Armstrong and Sir Bernard. You were involved in the early days at Jodrell Bank.
The very early days of Jodrell Bank. That great telescope was only a madman's dream in those days. And Bernard was working on radar, and he wanted meteor trails. And so a lot of us were lying on our backs outside where the telescope now is, plotting meteor trails.
This was inspired by the fact they'd seen during the war, right? They'd seen that they got radar echoes from things in space, from meteors. And so that became a whole new field of research. What was he like as a person, though, in his heyday?
Immense courage, total calmness under all situations, charm, he had that. If you tried to find the fault, it would be very difficult to do. Certainly I can't.
What was he like as a cricketer?
Very good batsman. I once had the pleasure of playing against him.
Who came out on top?
I really forget now.
I think one of the things that impresses me most looking back at Sir Bernard's life is how quickly things went from you lying on your back on Jodrell Bank to building what we now call the Lovell telescope, that enormous, fully steerable radio telescope made up of bits of battleship and
For which
high
Bernard was
technology.
entirely responsible.
But the project had quite a rocky start. It was expensive for
It was
starters.
indeed very expensive, much more so than the official quote had been. And at one stage, Sir Bernard was even threatened being sent to prison for overspending. But then a piece of real luck came along. The launch of Sputnik 1, the first Earth satellite, and outside Russia, the only telescope in the world capable of tracking it was what we now call the Lovell telescope.
That's right. It was easy enough to pick up Sputnik, but it was the rocket that launched Sputnik that you needed the telescope. And the Lovell telescope in 50 years has done an amazing amount of science.
And still is.
Yes, Jodrell's the centre of worldwide radio astronomy now, and that's entirely thanks to Sir Bernard Lovell.
But for Bernard, radio astronomy wouldn't be as advanced as it actually is.
Well, Sir Bernard was on the sky at night many times, but I particularly like this interview from 1981.
I was at the meeting of the Royal Astronomical Society when you first made your suggestion of a huge radio telescope. How was it received by astronomers?
I think my proposal for the telescope, for which I was eventually given £250,000, I think it was referred to one or two astronomers who said they knew nothing about the subject, and wouldn't it be better to build it in brick anyhow instead of steel? That is incredible, on looking back, that was the state of knowledge about this subject. It simply didn't exist.
And of course, while all of this was going on, we had the space race. Lovell was involved, and that brings us on to Neil Armstrong, who you also knew.
I knew Neil very well. He came to talk to me almost as soon as he came down from that first flight. He was quiet, retiring, never pushed himself forward, in fact, quite the reverse, and immensely competent in all he did.
And remarkably brave as well.
Don't forget, when they came down on the moon, they had only 4 seconds worth of fuel left, and he had to decide then, do I go for a landing, or do I abandon the landing, blast back into orbit, and give up the idea of being first on the moon? And to his eternal credit, he went for the former. We'll land. When I heard Neil's voice coming through, the Eagle has landed. I remember the feeling of overwhelming relief that came over me.
Neil's first space flight was on Gemini 8.
Yes.
And that nearly went badly wrong as well, with the docking.
It did indeed, but Neil rescued it by his calm appraisal of the circumstances and brought it back under control.
Easy enough to say, but calm appraisal while you're in a spacecraft that's spinning, docked to a lifeless piece of junk that's also spinning. It must have been terrifying.
Must remember too that when Neil and Buzz blasted off at the moon, they were going into the actual unknown. No one had done it. No one had even really thought seriously about it. But they were doing it and showing the way. Neil had to work it all out for himself.
He certainly did. A remarkable achievement. One thing I should ask you about, because you'll probably know, is the famous phrase, one small step for a man.
Ha.
Was that Neil's? I mean, obviously he delivered it, but was that some committee that came up with that, or was that him?
No, he meant to say, one small step for a man. And he said to me afterwards, I fluffed it. And the A got lost somewhere.
It did. But did he come up with the phrase?
Oh, yes. And he worked it out in great detail, practice, and still he fluffed it.
Well, we both know what that feels like.
Exactly.
It's one small step for man, one giant leap for mankind.
Mr. Armstrong, I needn't say what a great honour and privilege it is to have you with us for this evening's Sky at Night. I realised that when you were on the surface of the moon, you didn't have much time for looking upwards. But could you say something about what the sky looks like when you're on the moon?
The sky is a deep black when viewed from the moon, as it is when viewed from the space between the Earth and the moon. The Earth is the only visible object other than the sun that can be seen. The Earth is quite beautiful from space and from the moon. It looks quite small and quite remote, but it's very blue and covered with white lace and of the clouds, and the continents are clearly seen, although they have very little color from that distance.
When you were actually walking about on the moon's surface and kicking about a certain amount of dust, did you notice any local colour?
You generally have the impression of being on a desert-like surface with rather light-colored hues. Yet when you look at the material at close range, as if in your hand, you find it's a charcoal gray, in fact, and we were never able to find any things that were very different from that color.
We've put the full version of both of those interviews up on our website, so if you want to see them, go to bbc.co.uk/Sky at Night.
I think we always come out late. It's kind of tradition for the Sky at Night. We always have done.
Well, we've lost them, but their work lives on. And of course, work is going on apace. The Mars Curiosity probe is down on the surface of the red planet and doing marvellous work already.
Curiosity is NASA's latest mission to Mars. It's taken years to develop, and it's the most advanced vehicle ever to be sent to another planet. This is NASA putting it through its paces in the lab, and you can see how big it is. It's the size of a Mini, but it weighs over a ton. Thanks to a small nuclear power source, it should have enough oomph to climb a Martian mountain. On board are a fleet of amazing instruments. These test shots show the movable arm with its cameras and its spectrometers, which will be used to examine rocks. And it's got a laser which will zap rocks, telling the scientists if the rocks are interesting without all the hassle of driving up to each one. If they do turn out to be interesting, and I'm sure some of them will, Curiosity can test samples with its ovens and with its onboard chemical laboratory.
Fire!
But its size and its weight mean that Curiosity needed something really rather special to reach the surface.
Liftoff of the Atlas V with Curiosity.
Curiosity, then known as Mars Science Laboratory, was launched last November. And in early August, finally arrived at the top of the Martian atmosphere. With us to discuss Curiosity from University College London, Dr. Peter Grindrod, and of course Chris North. And Chris, it's been a really exciting couple of weeks.
It's been incredibly exciting. I mean, it all started for us early in the morning, on that morning, the 6th of August here, when Curiosity landed. An incredibly exciting event, because the landing was just so exciting. I mean, with everything that's going on, it had a sky crane and thrusters and a parachute and all these things to make the landing incredibly exciting.
The dreadful 7 minutes.
Yeah, the 7 minutes of terror, they called it, where for 7 minutes there was nothing they could do. It was running on its own. It's 14 light minutes away on Mars, so it took 14 minutes for any signals to get back. Absolutely nothing that could be done. And its target was Gale Crater on the surface, but it was an incredibly exciting journey down.
Pete, can you start talking us through what had to happen to get it safely onto the ground?
Yeah, sure. There are a number of things that had to happen. The first is to enter the atmosphere at the right point so that the heat shield could slow the craft down enough to slow it down from 13,000 miles an hour down to, about 1,000 miles an hour by the time the atmosphere had done its job, and at which point the parachute could then come out for the first time.
Parachute deployed. We are decelerating.
and the heat shield's ejected, and we actually had some amazing pictures of the heat shield. We got them later, not live. But the heat shield falling down across the Martian surface. It's quite remarkable to be able to see this in a descent.
We're down to 90 meters per second at an altitude of 6.5 kilometers and descending.
We even got a photo of Curiosity on its parachute.
From the Mars Reconnaissance Orbiter. And it's great to be able to see this, to have a spacecraft taking a picture of another spacecraft descending, but that wasn't the hard bit. What happened next?
Curiosity dropped down away from its back shell and parachute.
We are in powered flight.
And then moved away from the parachute and left it behind, and then started to descend on its own powered rockets then. So coming down, kind of 8 thrusters controlled it, slowed it down, make sure it was all smooth. It slows down to an almost kind of stop, hovering above the surface.
Sky crane has started.
So about 20 meters above the surface, then Curiosity, the rover part, then descended on its own kind of cables on this sky crane technology. This was the part that we'd never seen anything like this before.
You're stable.
Patrick, I don't know what you thought, but this looked completely insane to me.
I thought, this is not going to work.
UHF is good. Touchdown confirmed. We're safe on Mars.
Chris, why did they have to do this? Previous rovers had bounced to a stop, so why have this complicated sky crane?
Curiosity is the size of a small car.
Too heavy.
Yeah, it's too heavy. It weighs a ton. That's far too heavy to bounce down on air bikes, which is what previous rovers have done. The other problem is that it had to come down on these thrusters, but you don't want the thing to land on thrusters. You want it to land on wheels, so it couldn't have the thrusters on the rover itself. And besides, that's dead weight you've got to drive around. So once it's landed on the surface, this sky crane, this jetpack, if you like, has done its job and gets sent off to go and crash elsewhere on the surface, a few hundred meters away.
Well, out of the way.
Word came back that it was safely down, and then almost immediately we got the first images coming back. You could see that Curiosity was on a flat surface, it wasn't tilted, it looked safe, and then even straight away you could start to see some things in the distance.
Well, let's talk about the landscape, Patrick. You've covered more Mars landings than anyone else. What does Gale Crater look like to you? How does it compare to where we've been before?
Well, rather the same. Flattish, and all covered with red powdery stuff.
The sky pink, of course, which is now familiar, and rocks in the foreground as well.
Yeah, there aren't too many big rocks, but of course this landing site was chosen because there were few rocks there, because it's safest to go where there are no big boulders that could damage the rover. So that's not too much of a surprise. The thing that's affected me is the view. This is a view across the plain of Gale Crater, the floor of Gale Crater, which is very flat, looking towards the raised rim. It's about 2 kilometres high, the rim at this point, and it's quite eroded, so it's not a sharp crater rim, and it's a bit kind of hazy because there's dust in the atmosphere before we get there. But to me, it does look like Mars, but there's a kind of earthliness about this image. It looks familiar when you look at this image. You recognise features.
Is this Mars or Earth? Have we made some ghastly mistake?
Oh, it's definitely Mars. Definitely Mars.
That's why we needed that Mars Reconnaissance Orbiter shot of it on the way down.
I think one of the surprising things about this image is actually the scale. So the crater rim that we're seeing in that image there is something like 50 kilometres away. It's quite a long way in the distance. And as Pete said, it's 2 kilometres high. It's a big rim. It's the same area as Wales, to use a normal unit of measurement in areas. So it is a big place. And the other images we've got besides the rim, of course, are the central mountain.
This mountain in the centre, which is the reason we're at Gale.
Mount Sharp.
Mount Sharp. And it's a big one, right? What is it, 3 kilometres from base to top?
It's bigger, about 5.
So on Earth, that's like Kilimanjaro size, something like that.
It's massive, yeah.
Well, Mount Sharp is distinctive, but why is you there for this particular landing?
The reason that Mount Sharp's interesting is because it's 5 kilometres of rock, but more than that, it's layered rock. And these layers are almost like a timeline, a history of events, of the environments that have existed on Mars. And basically, the further down you go in this mountain towards the base, the further back in time we hope we can actually analyse. And the chemistry from orbit seems to suggest that down near the bottom of the mound, near the bottom of the layers, there was some kind of water around interacting with the rock and altering it to give it a different chemistry. Then as you move up the mound towards the middle, it starts to dry out. And even before then, the chemistry of the water might actually change as well. And then it dries out towards the top, where the top of the mound looks like it's probably always been dry up there. So this is not only a timeline of of rocks forming, throughout Martian history, but also recording the environmental change that seems to have happened in Gale Crater.
And so we go from a watery environment to one with maybe acidic water around. We've seen evidence for that elsewhere on Mars with Spirit and Opportunity, and then up to the dry present. That's the rough sequence we're after.
A good point here, the Gale crater is fairly typical of many Martian craters.
Yeah. Before we talk a bit more about that, why don't we look at the rover itself? Chris, what's it been doing since it landed?
So it landed at the start of August. The first thing it did was take some photos just to check where it is. It's got a mast that shortly after landing it had to deploy, so this mast had to lift up. And the mast is able to take a 360-degree panorama by spinning round. The rover is got 6 wheels, and all of them can be driven independently to give it full flexibility. But of course, one of the things it did a couple of weeks after landing was to actually drive a short way just to check that the wheels worked. It drove a few metres and did a little loop-the-loop.
One thing I noticed that was very odd, but predictable, when you look at those photos showing the wheel tracks, they appear to start in the middle of nowhere, which feels very, very strange.
It's almost like it just dropped out the sky.
Well, indeed, exactly, or was lowered out of the sky. So why is the arm important? What role does that play in the mission?
Well, it's a 2-metre-long arm. It's got this turret on the end that weighs 30 kilograms. That's more than the payload on some other missions to Mars in the past. And that arm can not only analyse the rocks up close with a hand lens, a magnifier, and a spectrometer as well, but it can also take samples from the ground. It can take a dust sample, or it can actually drill into a rock, take some of the material off the rock from inside it, and then bring the sample back onto the body of the rover.
Yes, and of course we have some ovens on board.
Yes, and there's 2 main instruments. One is an X-ray instrument that will look at the minerals inside the rocks, and the other one is a set of ovens that will heat up the sample to really high temperatures and analyse what's given off during that process, and from that understand the organic makeup of the samples.
But you can't put much material in each one. We're talking what? Just a pinch of soil, something
about
like
40 milligrams, a very small amount, a pinch of Martian dust or rock into the instruments on board.
Up to now, each probe has done what previous probes have done, but done it better. But this one is entirely new.
It's a league above the rest, right? It's got 10 instruments on board.
I think the one that's got the most attention, just because of what it is ChemCam, which comes with a laser, and quite a powerful laser at that. So if you'd like to explain why we put a robot with a laser on Mars, I think that might be good. It sounds like something out of science fiction.
It is, absolutely. I think we do it because we can. It's a great instrument, so it means that rather than having to go up close to a rock to either take a sample or analyse it in situ, you can actually fire this laser from up to about 7 metres away and analyse what the rock is made of. And then that gives you results in itself. The laser vaporises the rock and you can analyse the plasma that's given off. But then if that's really interesting, then actually maybe we want to drive over there, take a sample and analyse it in even more detail on board.
But it means your first step doesn't have to be to go and get a sample.
Absolutely, yes. And it also means we can access rocks that otherwise we wouldn't be able to drive up close to.
I should know the answer to this, but I don't. How long do you expect Curiosity to go on working?
Well, this is why Curiosity is a completely new kind of mission, because it's designed to last for 1 Martian year, which is almost 2 Earth years. It's not in any rush to start driving quickly. It's doing a very thorough checkout of all the systems and instruments first, and the science will slowly pick up over the months and years.
One of the reasons that Curiosity can last for so long is that it's actually got a nuclear generator. This power source will work 24/7, or 24.5/7, because the Martian day is 24.5 hours long. So not only has it got a laser, it's a nuclear-powered laser robot, which is quite fun.
It's pure Doctor Who.
It really is. It really is a nuclear-powered lasered robot. But to get back to the science, it has shot its first rocks.
The first target it shot with a laser was part of the commissioning phase of that instrument and the rover. And it looked like, it kind of seems strange to say this, but like a typical Martian rock. We're used to seeing rocks on Mars now. It looks like it's kind of a typical Martian basalt, a lava basically on the surface.
So a basalt, just like we might have here on Earth?
Yes, very common on the Earth and on Mars as well. Mars is predominantly a basaltic planet, but it's how these rocks, these basalts, have been altered by water that ultimately has chosen, Gale as the landing site.
Well, let's talk about driving for a second. Chris, when we say driving the rover, I mean, it's tempting to think of somebody with a joystick, but of course it's not that.
Well, the rover drives based on a series of commands that are sent up to it the day before. So every day, the rover operations team will send a bunch of commands and tell it what to do for the next day. They will tell it, drive 30 metres in that direction, and it will just go in that direction. It has hazard avoidance cameras that will warn if there's something in the way. So if it finds a particularly big rock, or if it discovers that one of its wheels might be slipping in soft sand and therefore risk getting stuck and so on, it will stop and say, well, tell me what to do.
How fast can Curiosity go?
It's not very quick when it's actually driving. It's only about 30 metres an hour as an average, the same as a garden snail, I think, yeah.
OK, well, I can imagine that. It's a robot nuclear-powered laser-equipped snail on Mars. I can just about get my head around.
But Curiosity is designed to drive for 20 kilometres. The science targets are only 8 kilometres away, so hopefully it can drive much further than that.
So what is the first science target? Where are we going?
We're going just to the east. It's about 400 metres, a target called Glenelg. And this is interesting to the science team because it seems like there are 3 different geological rock types that we're looking at from orbit, from spacecraft images. And so they have different textures, they may have formed in a different way, they might have different chemistries when we look at them up close. And so each one of these can tell us a different part of the history of that area.
What does understanding Gale tell us about the possibility of life on Mars?
Well, understanding the geology tells us that, what the environment was like when the rocks were laid down and how they've changed. Now, it's the environment of Mars that, tells us how habitable areas like Gale Crater actually were in the past. And so we understand whether life as we know it, if it had the conditions necessary, so if it had liquid water or the energy or the right elements present to actually survive on Mars early in its history.
But Curiosity's not actually going to ask, was there life there? It's just going to ask, was it habitable? Could there have been life there?
I've seen a few people talking about fossils. Is there any hope at all? Or you're talking about sedimentary rocks, after all, which is where you find fossils on Earth.
It is. I mean, the cameras will be capable of seeing anything like that, but we don't expect to see anything as big as fossilised, on Mars. Instead, when we're talking about life, the possibility of life on Mars, we're talking about microbial stuff, very early in its history and very, very small. And so the instruments on Curiosity are designed to analyse the organics, the rocks, the minerals and things, but probably isn't capable of actually finding those microbial stuff.
All I will say is that I expect the unexpected. Well, thank you, Peter, and both Chris's. So there's a lot to see in the September night sky. Over now to Paul Abel.
Well, we'll come on to the September night sky very shortly, but first we've come to a rather special observatory. It's one we've not visited before, and we thought we'd do a sort of astronomical through the keyhole. So I'll give you some clues, and why don't you see if you can work out who it is we've come to visit. Well, we're inside, and look! A long-suffering astronomer's wife.
Hello, Paul.
Hello, I'll talk to you later if that's okay. And outside, telescopes. Let's go take a look. Well, look at this. This is an immense telescope. This is actually a very specialised piece of kit. It's called a C14. So have you guessed who it is yet? Let's go and see who's in the Astro Wendy house. Hope he's in.
Hello, Paul.
Rather quick. Did you guess who it was? We thought we'd come and visit your Astro Wendy house.
Why do you call it a Wendy house? This is my astro cabin. This is where I do all my setup for observing. Out there is where I do my observing.
Let's go and have a look and see what's in the September sky.
Okay.
So you don't have an observatory then, this is where you observe from?
I like to be out underneath the skies. I don't like to be constricted in an observatory. I feel more connected to it like
yeah,
this.
it is lovely. I have to say, I've seen the Milky Way from this garden. It is spectacular. It just sort of arches over. You've got no light pollution. It almost casts shadow. I'm very envious. Anyway, on with the night sky, September. So Venus is going to be having a nice little encounter with the Beehive cluster.
It is, Messier 44, as it's also known.
Lovely object.
It's a beautiful open cluster right in the heart of Cancer the Crab. And between the 10th and the 16th of September, Venus will pass just underneath. It's about 2.5 degrees. That's about 5 moon diameters, if you like.
So it's quite close. And this is a wonderful object, in my opinion. It's the only thing worth looking in Cancer. There's not much else in there. It's very easy in binoculars. Telescope at low magnification will show. It's just a great thing, isn't it?
It is, absolutely.
Well, Venus isn't staying in Cancer, it's going to move along to Leo, and in particular, it's going to have yet another encounter, this time with the star Regulus in Leo, isn't it?
Yeah, actually, this is going to be quite exciting, and I'm going to throw a challenge open to the viewers with this one, because at the end of the month, about the 30th, if you get up at 4 o'clock in the morning, you'll see Venus really close to that bright star Regulus in Leo, the Lion. Now, if you can follow it over the next few days, it gets closer and closer to the star. Pick it up on the 3rd of October, and you'll see Venus really close to Regulus in the morning sky, about 4 o'clock in the morning. But if you can keep with it and you've got a telescope, wide field, watch Venus as the sun starts to come up and Regulus, and you should be able to keep both objects in view, even though the sky has gone bright blue. And that's amazing, because you can then see a star.
I tell you what, if you get any images or drawings, get any images or drawings of that, bung that on our Flickr site, we'll have a look at those. That'd be interesting. Can you see me? Do you think you'd be able to see that in binoculars?
A star in binoculars during the day? I'm not sure, actually. I can't see any reason why not, but it might be a bit on the threshold of visibility.
We'll see what we get. I mean, it'd be cloudy anyway, so it doesn't really matter.
Always the optimist.
Always the optimist. OK, let's move on to the rest of the planets, because Jupiter, wonderful Jupiter, has returned to the morning skies, really very bright, and it's now in the northern hemisphere, so getting quite high. And we've had some interesting changes on the planet.
Well, the North Equatorial Belt is really, really complex at the moment and very thick as well.
It is. Well worth taking a look.
But the really stunning thing about Jupiter for me, I saw it the other morning, is that you go outside and you can see it there in the sky, and it's in Taurus, the bull. So you've got the Pleiades, you've got the Hyades, Aldebaran and Jupiter. And together they look amazing.
I'm never tempted to look at the deep sky objects, so not when Jupiter's about. OK, another planet of interest is the planet Uranus. A tricky customer because it's hard to find, and it does have this reputation of being very bland. But if you persevere and stick with it, you do need a larger telescope for this. But it looks like there has been some banding appearing, some zones appearing that are brighter. Certainly it's not dead and not inactive, and it's well worth keeping an eye on, because I wouldn't be at all surprised if, storms and things do appear on that planet, and, if nobody's watching it, we'll never know.
Not an easy place to find. It's in Pisces at the moment. And it's off to the left, if you like, of the Circlet asterism.
Good. My technique for doing it is to search around the area with binoculars and then put your telescope on it. I find that's the best way to do it.
And it looks really green.
It does. It looks like a little emerald shining amongst the stars of Pisces. Well, lots of lovely things to see in the September sky. Let's have some clear skies.
Yeah,
and look,
definitely.
some tea. And here she is, Tessa.
Nice hot cup of tea.
Oh, thank you.
Thank you very much.
Thank you very much. We should introduce this charming lady. This is Tessa Lawrence, long-suffering wife of Pete Lawrence.
As all astronomers' wives are.
Tell us, what's it like? What's it like to live with Pete? You be quiet.
I think the worst thing about being an astronomer's wife is that he never shuts the door.
Oh.
And he doesn't feel the cold. So there's a constant draft.
He does when we're out camping. He never stops whinging.
And when it all gets too much, I just banish him to his Wendy house.
Yes, it is a Wendy house, isn't it?
It is a Wendy house.
It's a Wendy house. Anyway, thanks for inviting us over.
It's a pleasure.
Let's hope for clear skies. Cheers.
Next month, we're going to look at the autumn and winter skies and do the second part of our More Marathon. Until then, good night.